Good evening, friends. So today we are going to learn a very interesting concept of research. So this concept is called moderation. So before going to the slides, I want to explain you in my language. Now, so I am asking a very simple question to you. I am taking two things. One is independent, that is X, and second is Y. Like, for example, so I am providing the training. So I am providing the training and you have training quality as per your perception. And the Y is the performance. Okay. Now, this training program is expected to improve your performance. So my question is, can I say that this relationship is measured by beta? Beta is representing the impact of X on Y. Now I have some questions. Can I say the impact of X on Y is different for male and female? G stands for gender. And I want to check whether this impact of X on Y is different for male and female. Means I want to say the beta for male is different and beta for female is different. So then it is called moderation. And even I also want to know whether this relationship is different for young and old, whether this relationship is different for scholar and faculty, right? So the question is that whether the impact of X on Y is different for different people. Now let's understand some layman example. Suppose I am taking here is the food intake or the calories. FI means food intake. So every day we eat food. And this will impact what? The increase in weight. So this is a weight. So we eat food and this will increase or decrease our weight, depends upon the how much food you take. Now the relationship, this relationship, can I say this relationship is different for young and different for old? Answer is yes. If young take more food, even then their weight will not increase. But if old take same food, their weight will increase by much. So the impact of food on weight is different for young and old. And the reason is their metabolism. The metabolism of young people are more and the metabolism of old people are yes. So age is a moderator in this. So this is called category moderation. Categorical moderation means the impact of X on Y is different for different groups. Like UTED theory say that the impact of social influence, social norms. Social norms means what is going on around us. So the impact of social norms is higher in females as compared to males. So females are more influenced by the society. So their behavior are more influenced by the society. Male is not having that much effect. So this is called moderating effect. And if I show you like, so I'm just trying to show you the Google. And if I type here UTUAT model. So it is a famous model for examining the technology acceptance. Now, let's say I'm showing you this image. You can see this image. The impact of the social influence on the behavioral intention is different for different gender, age, experience, and voluntarily of use. So these four variables are moderating variables. So these variables are moderating variables. So whenever you see this kind of relationship, and we are connecting them with the arrows between them. So meaning of this arrow is this relationship is different for male and female. So in this way, we understand the moderation. So you can see that in all these examples, we have a lot of arrows like this. So all these are the examples of moderations. Now, come back to our original example. So I will show the moderation like this, and I will put here age. So age is having different relationship. The impact of food intake on weight is different for different age group. So this moderation is known as category moderation or group moderation effect. Now I want to add one more variable into it. I personally found that there is another variable, but it is not category. It is the amount of workout or exercise. So in simple language, let's say it is exercise. EX means exercise. So now I put exercise like this. Now I want to say the convey, meaning I want to convey here. So I am dividing the people into two groups, not actually in groups, but I'm saying that those who are doing the high exercise, those who are doing the low exercise. And exercise here is not a category variable, it is a continuous variable. So I want to say, if this exercise increases, it is from low to high, the impact of food intake on increase in weight changes. So it is a moderation effect. Now then I have to tell that what kind of moderation I am expecting. So I'm asking a question to you. So tell me, if somebody who is doing no exercise, irrespective of the age, irrespective of the gender, if somebody is not doing any exercise, the impact of food on the weight is high or low? So you can tell me high. If somebody is not doing any exercise, the weight increase is high, right? So for a low, the impact of food on weight is high. If somebody is doing high exercise, so even if he take more food, the weight will not improve, right? So we assume that the exercise is used to burn the calories, right? So that kind of exercise. Okay. So now I'm expecting the negative relationship. Why negative relationship? If level of exercise increases, the impact of food on increase in weight decreases. So this is called negative significant moderation. So whenever I say negative and significant moderation, it means if moderating variable increases, the impact of X on Y decreases. So this is the example of continuous moderation. I'm giving you another example. So you know that if you read, you will get more marks. So reading leads to more marks. Now I'm challenging that IQ is a significant moderator. So now consider this level of IQ. So somebody is having the low IQ and somebody is having the high IQ. Now, first I consider for a low IQ. If a low IQ person read it, so do you think the impact of marks is high or low? Answer is low. So beta is low in this case. Beta is also low for a low IQ person. For a low IQ person, impact is low. Now, so I can write here low beta. So for a person who is having low IQ, the impact of reading on marks is low. Now somebody who is having the high IQ. So what is the impact I am expecting of reading on the marks? Answer is high. High beta. So anybody who is having high IQ, having the high beta, low IQ, low beta. So I can say this moderation is positive and significant moderation. So the moderation is positive and significant moderation means, so what is the meaning of this positive? The positive means this moderator increases the impact of reading on the marks. If IQ increases, the impact of reading on the marks will increase. So I hope you are getting the sense of moderator. Moderator. It is very, very important concept. So I gave two examples to you. One on a categorical moderation, like male, female, married, unmarried, young, old, businessman, and serviceman, like that. So the group moderation is very common, is very, very common in the theories. And the interaction moderation is also very useful, right? Because in theories, there are many moderators like this. So if we want to check the moderation effect, then how to incorporate all these things? So we are going to discuss today. So by these examples, I hope you have the idea of moderator. So in simple language, just I'm summarizing. There are two types of moderators. One is called category moderators. So it is a category like male, female, like that. Second is called continuous. Those are both are started with C, but it is continuous variable. And in case of continuous variable, we called it interaction effect. So it is a continuous variable. It is a scale variable. It is a nominal variable. It is a scale variable. Now, how we are defining the moderation in continuous? Sorry, for first of categorical. If the impact of X on Y is different for male and female, is different for young, middle, and old, is different for married and unmarried, then this is called continuous categorical moderator or group moderation effect. This is called group. So in simple language, we call it group moderation effect if the impact of X on Y is different for different groups. Similarly, in continuous, we are saying when the impact of X on Y is changing with third variable, is changing in the presence of third variable, third scale variable, that is called continuous moderator. Like impact of food intake on weight gain is moderated by the exercise. The impact of reading books on the marks is moderated by the IQ, like that. So now I hope you have the basic understanding of the moderation effect. In Smart PLS 3 and Smart PLS 4, there's a drastic change of applying the moderation in Smart PLS. In Smart PLS 3, the system was entirely different. In the Smart PLS 4, the method is entirely different. So there's a significant difference between the way we have to apply moderation in Smart PLS 3 and Smart PLS 4. In Smart PLS 3, we don't have this facility to add these arrows. But in a Smart PLS 4, we are having this facility, so you must know this. Now, let's go to the... So we are going to do this exercise today. And this is a moderator. We can take group moderation. We can take continuous moderation. In both cases, moderator is coming like this. So whether your moderator is categorical, whether your moderator is continuous, the method of applying is same. Now, let me explain from the basic. So I hope I already explained this. So whether the impact of X on Y is different for different categories or is different for different level of M. That is called moderation effect. Okay, so moderation analysis is used to examine how the effect of X on Y depends on the third variable M. Okay, so these are the definition of moderation, and this is the way we can use the moderation. So one thing I am also telling you, mediators are the part of the model. So if you remember the mediation is always comes in the model, but moderator is not inside the model. Moderator is outside the model. Mediator is the insider. It is inside the model. Moderator is the outsider. It is outside the model. So model is different. It is an outsider variable. The effect of X on M, X on Y is said to be moderated if its size or direction. So there are two things, size and the direction is dependent on M. It tells about the conditions that facilitate and okay, so this is the basic definition. I already explained that. Now this is important. There are two types of moderations. One is categorical or group moderation effect, and the second is continuous or interaction moderation effect. So continuous or interaction moderation effect. Now, if you check these lines, so we are having two categories, B1 and B2. We are having two categories, B1 and B2. So for B1, the line is different. B2, the line is different. Now, B1, in case of B1, if A increases or if X increases, Y increases because it is upward sloping. So if A increases, Y also increases. So it is a positive relationship for B. In B2, it is a negative relationship. So it is because it is downside moving. If X increases, Y decreases. So nature of the moderation is different for B1 and B2. It is also a moderator. In continuous moderator, normally we mathematically, we multiply predictor with the moderator and it is a now third variable. So we want to check whether this third variable is having the impact on Y or not. Because we are multiplying X and M, right? Suppose this is X and this is M. M means moderator. So what we do, we multiply X with M. So this is X multiply with M. So it is now it is our third variable. So we want to know whether this third variable is having the impact on Y or not. So this is the way we apply moderation effect in continuous or interaction variable. So that's why, because we are multiplying X into M, this effect is also known as interaction effect. So interaction effect, continuous or interaction moderation effect. In this case, we call categorical or group moderation effect. Here we are having the continuous or interaction moderation effect. In Smart PLS, you can even calculate interaction effect in groups. It is a facility. So I am showing you how we can do that. And we can also apply group wise group moderation effect and interaction moderation effect in here. So we have both the choices. Okay. Now let's see. So these are the different examples. In Smart PLS 3, we make this diagram, but now we are not making this diagram. The diagram is different, but the calculation is same. So how the software calculate the moderation effect, I want to explain. Suppose you are having independent variable. In this independent variable, we are having two items, x1 and x2. Similarly, we are having a moderator variable. It is a continuous construct. The moderator variable is also measured by m1 and m2. So when I am saying we are multiplying x with m, so x1 multiplied by the m1, you can see that x1 multiplied by m2, x1 m1, x1 m2, m1 m2, x2 m1, x2 m2. So we are multiplying all possible items with x and m. So after the multiplication, we are having the four new items. 2 to the 4, 3, 3 the 9. So you can see that if we have three items in x, 3 items in m, so we have 9 items in this. So this construct, this is a new construct. This construct is known as interaction construct or a moderator. So we will add this construct and see its impact beta. So we want to check whether this beta is significant or not. If this beta is significant, we can say the moderation effect is significant. And if this beta is insignificant, then we can say there is no moderation effect. So moderation effect is examined by beta. So we have to check whether this beta is significant or it is insignificant. But now in the Smart PLS 4, the diagram will be different, but result will be coming for this only. So just see this diagram carefully. When I was when I will do it, I will show you that how they are connected to each other, how the diagram is connected to the results. So I will definitely show you that. Okay, let's go to the next slide. Multi-group analysis is for the group moderation effect. In Smart PLS, we are having a feature. This feature is known as PLS MGA. So I will show you that PLS MGA, and there's a technical procedure for doing that. So what is PLS MGA? PLS MGA is a method to calculate the group moderation effect. So in one line, I can explain what is PLS MGA. PLS MGA is a method of performing group moderation effect for group variable or categorical variable. So now I'm going to do this exercise in Smart PLS, and I will try to show you each and everything in detail in Smart PLS. So I will show you two things: how the group moderation can be performed, how the interaction moderation can be performed in Smart PLS. So I'm going to open the Smart PLS. Creating a new project. The name of the file is moderation. So I put here 5 so that it come in the beginning. Import data. So in this file, you can see, if I go to the data, so these we are having the age, gender, education, marital status. So these are the categorical variables. And we are having some moderator in this. So performance expectancy is the independent. Social influence is the is also independent, and behavioral intention and usage behavior, these are the mediator, and it is dependent or endogenous construct. So now I'm creating a model, a SAM model. Moderation. Now, this is my performance expectancy. So I'm hiding it. Items are not required. Social influence. And we have behavioral intention. And we have usage behavior. So this is a model, actually simple. Now I want to connect. Okay, so this is my model. And I'm introducing a moderator called habit. So this is a moderator. So I am putting here moderator. This is my moderating variable. And I want to check whether this moderator is significant or not. So if you want to check the moderating effect, you just connect. Okay, you can see that it is moderating effect here. So we are having an option called moderating effect. So you have to highlight that first of all. So when you highlight it, and then you can take the arrows like this. So these effect only comes when you highlight this moderating effect option. This option is available in a Smart PLS 4, but not available in a Smart PLS 3. This is the model is complete. It's very simple. So if you want to apply continuous or interaction moderation, for interaction moderation, this is the method of connecting the moderator. And now do nothing, just calculate bootstrap. So we are performing the bootstrap procedure here. Okay. So the P values, you can see it is 0.002, 0.00, and 0.03. It means all the three relationship is moderator. And let me check the beta values. Okay. So now we are having very interesting result. This is positive and significant. This is positive and significant. This is negative and significant. So first of all, I will explain that what is the meaning of that. So let me show you in detail. I am going to edit. So these three relationship I want to. So here I am not having the option of editing. Okay. So this is 0.089 and it is significant. So how we can explain it? So performance expectancy is having the impact on behavioral intention. And our independent, the moderator is habit, right? Habit of using the digital equipment. Like you can understand like that. It means if somebody is having the high habit of using their digital equipments, so why I'm saying digital, because we conducted this study for UPI payment. So if somebody is having the habit of using the mobile phone and the digital tools, the impact of performance expectancy is high on behavioral intention. So this is the meaning of positive interaction, positive moderation. Similarly, this is social influence. BI is behavioral intention and moderator is positive. So it means if somebody is having the high habit, the impact of SI on BI increases. So with increase in habit, the impact of X on Y increases. Similarly, but if I check this is negative and significant. If you check this relationship is negative and significant. Negative and significant. So negative and significant means with increasing habit, the impact of behavioral intention on usage is less. So if habit increases, the impact of BI on usage decreases. So with increase in moderator, the BI X is having the low impact on usage, right? So this is a negative moderation effect. So we have negative moderation effect in the exercise. You know that with increase in exercise, the impact of food on exercise on weight gain is less. So it is the opposite, reverse moderation. So negative moderation means reverse moderation effect. So I hope you understand it. And what to report in this? You just go to the report, open report, and path coefficient. Copy this path coefficient here and open the Excel file. So now I'm showing you how this moderation effect is reported. Because in moderation effect, the most important is this. This, you can see this line. So this line, this blue line is indicating that moderator multiplied by PE to BI. It means between the effect of PI and this, okay. So this was a mediation result and I'm taking this result from here and paste the result here. So if you want to see the moderation effect, you have to remove this. Now, this is the table you need to report. So this is the path coefficient. This is standard error, T statistic, and P value. So here you can put hypothesis. And here you can see the remark. So this is hypothesis 1, 2, 3. And here you have to put like supported and supported and supported. Why? Because all the P values are. So normally P values we don't include, rather we put a star here like that. So this is the way you can show the moderation effects. So in moderation effect, these three lines are very important. Now, whenever you see this multiplication, moderator multiplied by P. So this is called interaction effect between moderator and P. The impact of moderation and SI on BI. So this kind of table you need to report in moderation effect. So I hope it is clear now how to run moderation effect. It's very simple. Okay. So remember that we have to check only the multiplication values. All other values are the part of structural equation model. So this part we have to show only SAM. In moderation, we will not report this. So we are nothing to do with this relationship. So only thing is that you have to show the moderation effect. Okay, now let's go to the group moderation effect. Suppose I want to check the group moderation effect. So I have two options. First option is that I can do it in the same way. Like for example, I can put it gender here. So clicking on the moderation effect, uh, so this is method number 1. Group moderation effect, we can do it two ways. By doing the interaction effect and by applying the PLS MGA. So we are having two methods. So I am showing you the first method first, and then I will move to the method number 2. So this is the interaction effect of gender on the three relationships. So run it, apply the bootstrap, start calculation. Okay. So in this case, you can see that only one relationship is significant and these two relationships are insignificant. So we can, you can report like this, so you can make some changes. So that is not a problem. I'm just doing you this to show you the beta values. So these two relationships are insignificant because p value is more than 0.05. And this relationship is significant because p value is 0.04014. Now, what is the meaning? Because we normally give 1 to male, 2 to female. So it means when you move from male to female, the relationship will come down. So the impact of social influence on behavioral intention is less for female and more for male. So according to the results. So this is a significant moderation effect. Now, if you go to the path coefficient, this value is significant. So the effect is this minus and significant because p value is significant. So it is minus and it is significant. So there exists negative significant moderation effect between social influence and behavioral intention for male and female. So this is the method for doing interaction effect for categorical variable. So you can do like this also. But in Smart PLS, we have another method called MGA. So now I'm showing you how to do it MGA. Go back, save this. And first of all, we have to go back because the process is totally different. First of all, you have to click on the data. So when you click on the data, you can see the option called generate groups. So first of all, we have to define the groups for group moderation effect. Why I'm doing so? Like I'm just showing you, this is my model and let me remove this. If you calculate, you can see that bootstrap multi-group analysis is inactive. It is not highlighted. You can see that if you click on this, nothing happens. So bootstrap multi-group analysis is highlighted only when you define the groups. So for defining the groups, I am going back and click on the data. This is my data. So I click on the data and I am going to the generate groups. Now the software is showing you that you are having so many groups. So which group you want to generate? So first of all, I'm generating the gender. So in gender, the software is showing me 3 groups. There are 3 groups in gender. Okay, apply. So, okay, in fact, we have 2 groups. There is no 3 groups. Why software is showing 3? I don't know. So group number 1 is having 142 and group number 2 is having 211. And software will take the group only when you are having at least 10 cases. Otherwise, it will remove that group. So it may be possible that we are having 1 or 2, 3 values. So group number 1 is 142. This is male. Group number 2, 211, which is female. So now I want to edit it. So my group number 1, I am replacing it with male. Apply. So you can see that now the name of the group is coming here. Similarly, I want to do the same thing with group number 2. Edit. Group number 2 is female. Apply. So now we are having proper names, male and female. So this is the step number 1, that you have to create the data groups. Then go back, go to the model. And after this, you can see that it is highlighted. Bootstrap multiple group analysis is highlighted. Otherwise, it is not highlighted unless and until you make the groups. So now I click on this. Now the software is asking which you want to compare. So I want to compare male with female. So you have to select that between which group you want to make comparison. So I want to compare male with female and start calculation. Do nothing, just do start calculation. Now software is doing the group modulation effect. And it is a technical procedure. So I am showing you step by step how we can do that. Now I got the result. So where is the result? If you go to the path coefficient, so software is showing you the difference of male and female, whether it is significant or p-value. Unfortunately, we don't have any significant here. Even if we saw this, in interaction effect, it was significant, but here it is not significant. So sometimes the different result comes in group modulation effect and the interaction modulation effect. So you have to check both ways, and wherever it is coming significant, you can report that. Now, how to report it? That is the most important thing. So I will take this. So you can see that we are having so many tables here. So first of all, I go for Bootstrap MGA. Then I go to the parametric test. Or there are many facilities here. So what we have to select? One is, there are 2 options, Bootstrap MGA or parametric. More or less, they are same thing. Bootstrap MGA means it is coming by bootstrap method. And parametric test means if you assume that they are normally distributed, you can check this. So you have both the options. If you go for bootstrap MGA, it means that software is running on different samples, and this is the average of all the samples. And parametric means no bootstrapping is done. It is just assuming that if it is normally distributed, this is the result. So normally if we go for Bootstrap MGA, I'm taking this table and pasting in Excel. So first of all, I want this table. Second, but this table is not sufficient alone. I have to take the Bootstrap result also. Because I am taking Bootstrap MGA, I have to show this also. So copy to Excel and pasting here. Now, how to make we have to combine this table in this table. So how to combine? So that is the most important thing I'm showing you here. Delete. Okay. So this is the combined table and it is highly technical to show the result. Okay. So you are having the original beta for female and original for male. So we don't want both. Now, it is the path coefficient for female and it is the path coefficient for male. So these two things we require. Rather than mean, you can take PC path coefficient, or I'm just putting beta. Beta for female and beta for male. So you have to report that. Standard error you can ignore, not a problem. So much result we are not needed. Now even this is not required. Now we want to check. So we are saying that for female, the beta is 0.52 for this relationship. For male, it is 0.43 for male. Similarly, when I check the impact of social influence on behavioral intention, the beta for female is less, the beta for male is high. Now the question is that, are they different or similar? So for this, we take the values from here. So this is the difference and the difference is coming like this. So I'm putting cut, pasting here. So this is the difference of beta of male minus beta of female. So for example, like this, 0.542 minus 0.442, this is the difference. Now the question is that whether this difference is significant or not. So I can make this difference small. Yeah. Now whether this difference is significant or not. So for that, I have to report t-test, one-tailed, two-tailed. So I go for two-tailed. And it is a p-value. So I'm putting here. So it is p-value. And now this is not needed. So I'm removing it. So this is the result I have to show in the thesis or a paper, that I am saying that no p-value is significant. So there is no significant group moderation effect. So it means the impact of independent variable on dependent variable is exactly same, not exactly same, but same in both the groups. So there is no group moderation effect. So PLS MGA say that there is no significant effect. There is no significant moderation effect in all the three cases. Now the problem comes when there are three groups, because in this case we are having only two groups, not a problem. But actually, when we have three groups, then it is a real problem. And more than three groups, it is just impossible to apply. So I'm showing you how to do this example with three group case. And first of all, you know that we have to go to the data, generate groups. Now I'm taking the age where three values are there. Apply. So we have now three groups, young, middle, and old. So I am changing the name. The first group is expressing the young people. Apply. The group number 2 is middle age. Apply. The third group is old age. So you have to put old. Now, if you want, you can remove the male and female. You just delete it from here. I am deleting it because we have done whatever we can do with male and female. So now I'm going to check the moderation with these three variables. After defining them, go back, go to the model and calculate. bootstrap MGA. Now we want to compare the old. So here you can put all, select all, because or permutation combination we can select. Otherwise you can do, you can check first young with middle, young with old. So you can do that also. So I'm selecting all because I want all combinations. All combination means young with middle, young with old, old with middle, old with young, like that. So that's why I am selecting all. Now software will give me all permutation and combinations. So calculation is going on. So we get the answer. Now go to the, so again, some, okay. So now we are having a long, big result. And it is quite complicated. So I'm taking this table first, bootstrap MGA. This is the first table I'm taking. And putting this table here. Then second table I will get from bootstrap result. Copy and paste, let's say here. So there are so many things. So we have to select. First of all, remove the original, because we are going to show the, so this is for, I have to rename it beta for middle. So first of all, I have to show the beta of, this is the beta for old. And the third is beta for young. Beta means path coefficient. Now, how to understand this? For example, if I want to check the impact of PI on usage, it means the highest effect is on young. So behavioral intention leads to usage highest in young. So this is the highest. In this case, the highest value is this. And here the highest value is this. So it is found to be significant, I think, because social influence on behavioral intention, it is highest in young, lowest in middle age group, right? So it seems that the impact is different in the different groups, right? And these are the beta, whether they are significant or not, you will get. Okay, so I should get t value also. So these t values are very important. And rather all the p value, you can see that 0. So I'm removing it. And you can put the star on these t values, right? So it is better to show only these three things, right? Okay. Now all the t statistic is showing you that the impact in all the cases is significant. Now the question is that whether the difference between them is significant or not. So that is the next thing. So I'm highlighting this. Okay, just making the border. So we have found that the impact of all the values are significant. So you have to show this report. And second thing, you need to show this. So this is showing you the difference, the moderation effect. This is the moderation effect. This is the impact and this is the moderation effect. So this is the difference between middle and old, middle and young, right? Like this. Okay. So one tail p-value, one tail, one tail. So all the three one tail I don't require. Now, these are the three p-values. So all the three values are significant. So I can put it. Yeah. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 moderation effects. So we have 8 group moderation effects. So what are the 8 group moderation effect? Like this. So this is the middle and young. So middle and young. So it means middle and young are different in terms of impact of BI on usage. And if you compare with middle and young, so the I think the young is high, right? So there are 9 moderation effects. It means there is a 9 significant different beta, 9 significant different beta, and all the beta are, you can check, all they are different from each other. Only these two beta are similar. Otherwise, all pairs are significantly different. So middle and old, you can see it is insignificant. So middle and old, this is similar to 0. So you can see in this way, we can check group moderation effect. This is so complicated, but once you do it single time, it will be easy. So in this way, we can check the group moderation effect. So we have two options of checking the group moderation effect, but one by interaction effects and second by the PLS MGA method. So we are having two methods for this. Okay. So in PLS, I think nothing is required after that. Okay. One thing I want to see, if I go for PLS algorithm, yeah. Suppose I click here, let me do one exercise. So you have some options of showing you the path coefficient of the 3. And you are having the option, you can show for the middle differently. You can show for old differently. And you can show for the young. So for all the 3, you can show the path coefficient like this also. So whatever relationship we are calculating here, we can show for all. So this is the additional thing which we can add in the moderation effect. So this is called group moderation effect. So that's it from my side. And today I demonstrated you the how to calculate group moderation effect, how to calculate continuous moderation effect, and with the help of the example. So in Smart Pillars, there is no other any other options we can do. So whatever options we have, I already show you that. So give me a minute.